Hey guys, Fru here. Welcome to the channel. So recently, I was doing research for a different topic, and going down the rabbit hole, I stumbled across this concept that was just fascinating to me enough to make this quick video about. So the goal is to bring awareness to this topic, and if nothing else, when the time arrives, and we're going to talk about what that time is, people might look back and say, "Hey, somebody did make a video about this ahead of time." So now, before we go and talk about the topic we're gonna be looking at here, I do have a question for us, and that question is, when did it start? So the question for you, if you can help me answer this question, is when did it start? Okay, when did it start? Now, I know asking that question, you might say, but Fro, when did it start? What do you mean? What started? Okay, so asking a question is actually right that when did it start without giving a lot of context, it's not good. It's not a good question, right? Because you obviously say what are you referring to? What started? Now, the what in this case we're going to refer to would be time. When did time start? But even asking this question is a little bit tricky because you might say, hey, are we referring to era or maybe eons? Or are we referring to eras for geological time or periods or even epoch or age, right? We know geological time kind of follows this format, and many age makes an epoch, epoch makes period, periods make eras, eras make eon. And when we say when did it start, when did time start, which of these are we referring to? It still doesn't answer that question for us. And so what we're going to look at here from when did it start, and just to get ahead of my joke here is, when did time start for computers? And if you think about it, it's a for folks who know this, it's a trivia question, but I'm just playing this along just to get us to think a little bit before we get into our question for today. When did time start for computers? If you think about the computer you're using, the cell phone, the watch, whatever it is you're using, according to that computer, in the system of that computer, when did time start for that computer? Is it age or epoch, which is many, many million years ago, or periods, which is even more so, or eras, which is, I mean, think about many, we're talking about hundreds of millions of years, or eons, which is just, yeah, you can imagine what we're thinking here. For your computer, when did time start? Now, I'm not saying that you cannot write time in a computer, but if what does a computer think about the start of time? So the interesting thing about this is that when the people who started computers, they thought about this, and they had to give a start time for a computer, and the start time that they gave for Unix machines. So the Unix start time was given as 0000 um, 00. And to be specific, they chose, the folks who did this chose a time in UTC, and they decided that that would be January 1st, 1970. So they just decided that for a computer, if you ask the computer what time is it, according to the computer, is going to look back to say what time is it from this date, which is January 1st, 1979, and it will count the seconds from that date and it will give you that time. Okay. And UTC, we know UTC here is basically, let's use a different color. UTC is basically the universal, is basically the universal time uh, coordinated. And we can make a different video about what UTC is. Okay. And the other thing about this is that 1979 is arbitrary, at least as far as I know. Arbitrary. Somebody just decided that. It could have been 1960 for all we know. But it just so happens that this is around the time when computers were invented. So, and then the last thing here is this. this last piece here, because computers work in binaries. So they don't look at time as the way us humans who would read this as January 1st, 1970. The computers will represent time in binaries. And so what the computer would do is it represents this 000000 as a 32 let's do 32 bit signed value. So for a computer, it's actually a signed integer. So a computer represents this time, at least at the time when this was created, as a 32-bit signed integer. Now, if we're familiar with a binary notation, I'm not gonna go into that here. I made a video very recently about bits and bytes, so just check on the channel and check out that video to understand how computer represent things in bits and bytes and how it translates that into what humans can understand. So I'll recommend that video. All right, but if we take a 32-bit signed integer and we drew that kind of on the number line, on the number line, and we have a 0 here. Okay, so if you remember, bit, how that gets represented is, if you have a 32-bit signed integer, you can represent things from 0 all the way to 2 to the power 31, but we have to minus 1 because we're starting counting from 0. And then, so that's the maximum that we can represent. And the minimum that we can represent with the 32-bit sign is 2 to the minus 2, because we're going from the negative side of the number line, starting from there. Okay, so again, if you're not familiar with binary notation and how that gets represented, check out my video that covers that. So this is what a computer can represent with a 32-bit signed integer, which is the start of time. So remember, we started with a little joke. When did it start? Okay, according to Unix, time started here, 000, and the specific date is this date. So if you look at this, it becomes really interesting, because what you can say is, now we have a limit. The limit is a 32-bit signed integer. But what is that specific limit if we were to translate, if we use up all the bytes or all the bits there, what would be the maximum? So what is this maximum? What does it represent? Not in binary, but in actual time. What would this represent? So let me make that in red. What this represents is the specific time of um 3 1407 UTC. And the specific date, if we convert from UTC into the actual date, the human readable date is the 19th of, I believe, is January 2038. All right, this is interesting. So if we go back here, let's just title our thing here as the 2038 problem. Now we give a title to the presentation, or some people might call it Y to I think I've seen Y2K38. And you might be this will bring, if you're old enough, I know some viewers of the channel are young, but if you're old enough, you might have heard about the Y2K problem, which was something that people were worried a lot about. And I'm not going to talk about that here. But now we're looking at the Y2K38 problem. So that's the title for let's go back. So that's the title for the discussion. So now what we've seen here is, on this date, on this specific date here, the computers which use the 32-bit signed integer will run out of space, because it's 32 bits. You can only put so much time, and once you've maxed it out, you're gonna run out of space. Just to let me just maybe go into a little bit more of details here for to really illustrate the point. So if you think about binary, and the computer store things in bits, and you have 0 0 0 0 0 So it's kind of 1, 2, 3, 4, 5, 6, 7, 8, right? And then you go 1, 2, 3, 4, 5, 6, 7, 8, and you keep going. Now, if you start putting values here, let's say um, you have 32 bits of this, and I'm just representing just about 16 here. You have 32 bits, and you do uh, 1, 0, 1, 0, 0 all the way to this space, and you keep representing these values. At some point, you're gonna read 1, 1, 1, 1, 1. Everything will be 1, 1, 1, 1, 1, 1, and this is gonna be 0. Well, once you've filled up everything with 1, 1, 1, 1, 1, now you're gonna have to fill this right side with 1, and then everything else would be zeros. Would be zeros. Let's use a bigger pen. Would be zeros. Now, when you do that, it's a problem because this is a signed integer. This value is signed. It's a 32-bit. Remember, 32-bit signed. So because this max is signed, the moment you, and they call this overflow, the moment you fill up everything with 1, 1, 1, 1, 1, 1, 1, and now you have to go to the next level to fill this up with 1, well, you end up with something like 1, like what we saw there, 1, 0, 0, 0, 0, 0, 0, 0, 0, 0, 31 times. Okay, because we have 32 bits. So you'll be 1, which is the 32-bit, and then everything else will be 0 zeros. But because it's signed, the computer is gonna look at this and say, that's a problem. What it would read is this is minus 2 to the 31. It will reset. It resets and comes back to this because it's gone to the negative side of things. And what is this minus 2 to the 31? Remember, this is epoch. This is epoch. This is the start of time. This is 000000 UTC, right? And um this was the first of, and this was what we saw as the first of January 1970, um the first of January 1970. All right, so this is epoch, which starts at 00000, and you keep adding, you add ones until when it maxes out here. Now once you kick, everything becomes 0, and now you've gone to the highest bit available in there, and you turn that to 1. Well, you're telling it that because it's signed, you're going now to negative. You've gone now to negative, so you're looking at minus 2 to the 31, and that's the reset. So when that reset happens, if you translate this, let's bring this slowly. If you translate this time into human readable format, this would be 20, 45, 52 UTC, which is, what is that? That is the 13th of December 1901. Whoa, that's a problem. Okay, so so in other words, the time here is 13th of December 1901, all the way to 1st of January 1970 here, and then all the way to 19th of January 2030. So we've maxed out all the bits. It's brought us back to the time before epoch, because the computer, once it maxes that out, it's gonna think that we've gone back before epoch, and now it's gonna start thinking the current time on the computer is this. But that's not correct, because by the time we reach this, it's gonna be, so we should be past this time here. So you might be you expecting the time on your computer to be this, but the computer is somehow, after this date, is gonna start thinking that time is this, and that's a problem, because with computer systems, garbage in, garbage out, and that's why people were very worried about Y2K. Now you might say, but Y2K wasn't a problem, so why should I worry about this? And by the way, this is so far out, right? A lot of people might think about that. To be honest, this is not something that I think you need to really lose sleep over. For one, be aware of it. Just awareness, I think, is it's good. And number two, people are already taking steps to go in and check their code to make sure that when this date eventually passes, so this date Y2K38, when this date passes and the computer has to do this reset, and the computer does that reset because it's reached the maximum byte or maximum bit. I keep calling it byte, the maximum bit, and it goes to the negative side of the signed value and thinks that this is 1901. That when that happens, your computer systems don't break. Okay, so be aware, and then number two is make updates to code, to any systems. Right, think about cars, watches, laundry machines, all kind of systems that have code embedded into that system that depend on time. So laundry machines, you might not even think about the laundry machine in your house, but that uses code. The moment you're clicking the button and saying, hey, wash this alarm after 5 minutes, that's time. It's time based. Think about your microwave, think about your refrigerator, think about all the things that are embedded that use code that is based on the 32-bit system. Right? Those things have to be updated, otherwise there'll be a problem. Now, the fortunate thing about this is that a lot of computers today, a lot of machines today, so many machines today already use 64 bits. And there are solutions around this already. Many machines today already use 64 bits. If I ask you what bit, if your Windows machine runs on 32 or 64 bits, a lot of people are already updated. And the truth is, for the most part, a lot of systems by this date, by 2038, which is not a terribly long time, right? To think about this, less than, as I'm making this video, that's less than 30 years, less than 20 years, even you might make the argument. All right. So 20 years is not a long time. A lot of people see 2038 and think it's a long time. It's not a long time in the grand scheme of things. So, um, given that we have a lot of 64-bit machines today, maybe this is not going to be a problem. But again, it's just something um, to be aware of. There are even people who really take this seriously because let's go to a bigger pen here. GPS systems, satellites, and many systems that are kind of out of mind still run on 32 bits, right? If you think about the satellite that was launched up a couple of decades ago, it's up there just running and doing its thing. um Usually you don't go take the satellite from there, bring it down to make your software update and put patches or upgrade it to 64 bit willy-nilly or randomly, right? It takes a considerable amount of effort, and imagine the thousands of satellites that are out there. Those are the kind of systems that people really get concerned about. But the beauty about it is there is enough awareness about this now that hopefully by that time, systems will be updated and this wouldn't be an issue. Very similar to how Y2K wasn't kind of the doomsday that people were so scared about. Okay, so if you haven't heard about the Y2K 38 problem. Hopefully, this video has brought you an awareness of it. And if nothing else, if this has no impact materially to your life, then look at it as entertainment. But if it does, you probably want to go back and start thinking about how you update your system. Before I just kind of wrap up here, for one, for somebody that works with data systems a lot, if you go to a database and you do a very simple command on your database, like select time on the database. So most database systems, if you do like select, uh, say Unix time stamp, and this will be homework. What time does your machine give you? Depending on what database system you're using, and I'm assuming you're working with a relational database, RDB, MS, you're working with a relational database. So whatever relational database you're working with, here's a homework for us. Go in, do select Unix timestamp, see what time it gives you, and see if this Y2K problem would be an issue for you if you run this statement after this date. Would that be a problem for you? The time you're getting. So take that time that you're getting converted to bits, and see if that system, or do your research to see if that system will be a problem for this. And if it's going to be a problem, if you run that command after this date, you might want to email your database vendor, but I can tell you a lot of them have fixed it already. But email them and say, hey, what are you guys doing about this? Right? um, they will probably chuckle when they get that, because there's still enough time, in theory. But that might just make your boss, think that you're very, very smart and you're very, very on top of things. And even if they don't think so, you still would sound smart if you really pay attention to things like this. All right, guys. So there you have it. Just a quick video for us to bring up something that I came across researching, something else for a different, for some different projects I'm working on. The Y2K 38 problem. Um, Again, it all comes down into when time starts. So we know in geological time, GT, time is broken into ages, epoch, periods, eras, eons. Eons are the longest time age. Many ages make an epoch, and many epochs make a period. Many periods make an era. Many eras make an eon. But in computers time start from epoch. So epoch in computer world is the start of time, and that start of time is 32 is 000 January 1st, 1970, which is a 32-bit sign, value to store time. And from there we've been counting time, and from there we've had time, or which will go all the way to January 19th, 2038. And when that time is overloaded, which means that all the values have been used and it does a reset, it's going to take us back to at least it would think is January 1st, well, December 13, 1901, which would be a problem. So systems have to be updated to systems like cars, watches, laundry, microwaves, satellite systems, in particular GPS, is almost everything that uses time of some sort, which is a lot of things today. Either would have been updated to 64 bits. There are other solutions which I'm not covering in this video that are being put in place to make sure that this doesn't become an issue. And then for us, the homework here, just to recap, is select, if you work with databases, go into your database, do a select Unix timestamp if that function is available, see what it gives you, and then also think about, would that be a problem if you run this same query, um, when that overloading happens, which is January 19, 2038. All right, guys. So there you have it. Again, thanks for watching to the end. You have been very awesome watching these videos. I have been through, enjoy making these videos. Please show your support if you like it with the like button. If you don't, that's okay too. Share this with somebody that might get value out of it. And I'll see you all in the next presentation.